So we're looking at the introduction to skew boreholes. We're going to have a look at the terminology that's used, because the terms are often one of the hardest parts to get to grips with. So listed out here are some of the key terms that we use when we're looking at skew boreholes. So we'll start off there at the start. Stratum. So stratum is a layer or plane of ore with uniform thickness inclined to the Earth's crust. So this would be our stratum here. This is our stratum of ore, the pink and purple. So we can label that there as our stratum. Head wall. So the head wall is the top surface of the stratum. So this would be this side here. So put in an arrow directly to that side. And we'll say head wall. And then we're looking at the foot wall. So the foot wall is the bottom of the stratum. So the foot wall is down underneath this side. Now the dip, the angle the stratum makes with the horizontal. So when we move up here to our little diagram here, the dip is the angle that the stratum of ore is going to make with the horizontal plane. We can imagine that we need to look at this stratum of ore straight in from the side, which is like we have here. And by doing that, we can get the angle that it makes to the horizontal. That's just a little sketch there to kind of make the link there to show what's going on when you're looking for the dip. Now that comes from some of these constructions down here, but we'll get to that later on. The strike so comes all the way back to when we would have been doing laminas, or even finding a line as a point. So the strike here would be this line here. And the strike is basically a line that we can look along to either find the thickness, we can find the angle. Back then we would have been finding a lamina as a line, looking straight in. So the strike here, the direction of a horizontal line on the surface of the stratum relative to north. So it would normally be on the surface up here. But obviously in a construction we wouldn't have a 3D sketch like that. It would look something more like this. So down here, way back when we would have been finding lines as a point, we'd have had the line that we know is horizontal in elevation, which means it's a true length and plan. We look along it until we find it as a point. So that would be our stratum there, because it's a true length. Or sorry, that would be our strike. And this is the same principle. So we're coming horizontal to a point, we're coming down, we're finding this point, projecting across, and then we're looking in that way. So that whole triangle just becomes a line ABC. And we can also find our dip there, which is the angle it would make to the horizontal. The outcrop. The outcrop is something that we'll come to in another slide, because that's probably one of the more difficult elements. It's the point at which the section of the stratum of ore lies at or above the surface of the ground. So that's something we'll come back to, because that is one of the more difficult parts to get the head around. Thickness as well. How thick is the stratum of the ore? So the thickness can be represented by these lines here. These are AHs, so we'd say AH up here, and that would be BH. So that's the line across the top, across the head wall, and then you have another line under the foot wall. What we want to see is we want to see those two lines as parallel. If we end up with a construction from over here and we end up with a line at an angle and a line that's level, that's not what we're looking for, so that'd be wrong. We're looking for the two lines parallel, and then we can take that distance there to be the thickness, but it has to be parallel. That's the key part when we're looking for the thickness, and that all comes back to using our strike, finding our dip, and plotting our points. We'll end up with another line up here. If that was our 3D, we'd end up with a second line that would give us our thickness.